All right, so we've got two review problems from yesterday. While I'm going around and collecting your phones, why don't you go ahead and do those two problems. First one, find the missing side, given that it's a right triangle. And the second one, determine if it's a right triangle, an acute triangle, or an obtuse triangle. All right, let's take a look at them. So the first one, zoom it in so you can see a little bit better. Find the missing side. So it tells you that it's a right triangle. So we can use the Pythagorean theorem. A squared plus b squared equals c squared. Say a is 6, so 6 squared. B is 12, 12 squared. Our hypotenuse is x. So I'm going to replace with x squared. 6 squared is 36. 12 squared is 144. Add that together, you get 180 is equal to x squared. I think that's 180. Yep. Take the square root of both sides. So leaving it at x is equal to the square root of 180. That was fine. And whatever, 13 point something, I suppose, is what it is. 14 point something. 13 point something. 13 point something. Just kind of remind you a little bit about what you did back in algebra. In algebra, when you've seen something like the square root of 80 as a radical, you did the tree, the prime factorization tree, and you would break this down as 9 times 20, 3 times 3, 4 times 5, 4 times 4, 4 times 4, 2 times 2. And then if it had a partner, you could take it out of underneath. That has a partner, so you can take it out. And then the 5 doesn't have a partner. So the reduced form of this would be 6 radical 5. Not something that I asked you to do today, but we're going to do something like this today, kind of. So I just wanted to kind of see it. You've seen it in algebra, but you probably don't remember seeing it in algebra. Second one says, is it an acute, obtuse, or right? So we use Pythagorean theorem inequalities. So 13 and 12 are my A and B because they're the two smallest sides. 16 would be my hypotenuse if it was right. 13 squared is 169. 12 squared is 144. So that's 300 and, what is it? 313? That's 313. 16 squared is 256. So that's 256. So 313 is greater than 256. So if you forgot to go back to yesterday's notes with our Pythagorean inequalities, a squared plus b squared was greater than c squared. So therefore, it's an acute triangle. And there's your solution. So that's what we looked at yesterday. Yesterday we looked at the Pythagorean theorem, and then we looked at the Pythagorean inequalities to figure out if it's a right, an acute, or an obtuse triangle. Today what we're going to talk about in day 2 is we're going to specifically today talk about 45, 45, 90-degree triangles and how we find the missing sides on 45, 45, 90-degree triangles. There's a specific way that we can set these up, guys, to find the missing sides. And you're going to see patterns that evolve. We're going to build tables to kind of help you do this. But essentially what we're going to do is we're going to try to find a shortcut to find missing sides of a right triangle. In this case, they're 45, 45, 90. Okay, so if we look at this first example, I've got a right triangle. I've got an angle down there. I've got two sides that are both 20 and 20. Okay, so that means we've got an isosceles triangle. Now, how do I know that the measures of those angles are 45? Well, if you remember what we talked about in triangles in the past, if the lengths of the sides are the same, the opposite angles are going to be the same as well. And if we know this one's 90 already, I go 180 minus 90. That gives me 90 left to cover these two angles, and it has to be the same. So if I divide 90 by 2, that gives me that I have what's called a 45, 45, 90 triangle. Okay. And because it's a right triangle, we can use the Pythagorean theorem to solve this. If you know two sides of a right triangle, you can always use the Pythagorean theorem to find the missing side. So let's just do that. So if I take my legs squared, so 20 squared plus 20 squared, that has to equal x squared. 20 squared is 400. So that's 400 plus 400 equals x squared. 400 plus 400 is 800. So that's the square root of 800 is equal to x. Okay, well, that's kind of a goofy number. If we punch that into the calculator, it's still going to be kind of a goofy number. But I'm going to break this down and write it as in radical form. We're going to kind of what we call simplifying the radical. Well, we know that it's 400, right? So 400 is going to be 40 times 20, right? 40 is 4 times 10. 4 is 2 times 2, and that's 2 times 5. So I've got that prime factorization done. 20 is 4 times 5, which is 2 times 2. So you see I've got all these little prime numbers here. Here, 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 and here. Those are all my 2's. And then I've got the primes 5 and 5 sitting right there. So you'll notice that I have one set of 2's, so I can bring that out. I've got another set of 2's, so I can bring that out. I've got a set of 5's, so I can bring that out. And I have this last little 2 that I got to leave inside. 2 times 2 times 5 is 20. So if I simplify the radical and I do all of that work, I get that the length of that side is 20 radical 2. And that's the length of the hypotenuse if we use the Pythagorean theorem. Well, what observation can you make if you just kind of look at it and ignore all of this stuff? And if I just went and told you that instead of doing all of this stuff over here, that the answer was 20 radical 2, what do you notice? What's the length of my leg? 20. So it's the length of the leg times radical 2. And that's what it is. It's the length of the leg times radical 2. That's all the hypotenuse is in a 45, 45, 90. It's the length of the leg times radical 2. So which would you rather do? The Pythagorean theorem every time, or know the special formula that if it's a 45, 45, 90, the legs are the same, the hypotenuse is the square root of 2 times the leg. Obviously, you want to be able to do the other one, right? Because if I look at this question now, I could go 7 squared plus 7 squared equals y squared. 49 plus 49 equals y squared. Y squared equals 98. Break 98 down and do all of that fun stuff. Or I could say that y is equal to 7 times the square root of 2. Because it's the leg times the square root of 2. And that's our rule for a 45, 45, 90. Okay, our rule says this. In a 45, 45, 90 triangle, the legs are congruent, because they have to be, because they're opposite of angles that are congruent. And the length of the hypotenuse is the square root of 2 times the length of the legs. And that's always going to be the case. So if you're a word person, there's the words. Okay? In a 45, 45, 90 degree triangle, the legs are congruent, and the length of the hypotenuse is the square root of 2 times the length of the legs. That's the words. Mathematics, word people. Some of us, not many of us, not me. Okay? Does it make sense to me? Yeah, words make sense, but if I look at it over here I've got the drawing of it. So if you're a visual type person, this picture says the same thing. The length of my legs are congruent. I labeled them both N and N. The length of the hypotenuse is the square root of 2 times the length of the leg. The leg was N. That's times the square root of 2. So if you're a visual person, this is going to help you out a ton. The way we're going to solve these is we're going to solve these by putting this table together. And it's going to sound silly if we're given the n value, because it's just whatever it is. Where it gets a little trickier is when I'm giving you the hypotenuse. Okay, so we're going to build this table to help us do this. And here's what the tables represent. The first column represents a leg. The second column represents one of your legs. That's why we've got the n and the n there. The third column represents our hypotenuse, which is going to be n times the square root of 2. Now you're going to be given a picture and you're going to be given one of these pieces. You're going to be given a leg or you're going to be given the hypotenuse. And you're going to be asked to find the rest of them. And we're going to use a table to do this. We found teaching this is the easiest way to show it. If you're given a leg, it's easy. If you're given the hypotenuse, it gets a little bit more difficult. Where this table really comes in handy is on Monday when we do 30, 60, 90s. It really comes in handy. Because if I look at this first example, I've got 5, 5. I've got a right triangle, so the two legs are congruent to each other. I need to find the value of x. So because the two legs are congruent to each other, I know that I've got a 45, 45, 90 degree triangle. Okay. Now, we're going to put a table together with this, and we're going to use a table to do this one. Now, I get it. All of you in here, you're you're going, why do I have to put the table together? The answer is 5 times the square root of 2. And it is. The answer for this is 5 times the square root of 2. Just by our last example, or our definition, it's the length of the leg times the square root of 2. And here's how we use the table. Okay. I gave you one of the legs. The leg length is 5. And you say I only gave you one of them instead of 2 of them. Say I just gave you 1 instead of 2. And I asked you to find both x and z. Okay. I know one of my legs is 5. So then because I know that, what I can do is I can put that n is equal to 5. Because I can put a little equal sign in between those two rows. So n is equal to 5. So now I know that this second column, it's n. So the answer is 5. The third column is n times the square root of 2. Well, I know that n is 5, so that has to be 5 times the square root of 2. So the length of the hypotenuse is 5 times the square root of 2. The length of the leg is 5. And I'm done. The second one, it's kind of that same thing. I'm given my two legs are 10 and 10. So I know I have a 45, 45, 90. Could most of you just say, well, that's 10 times the square root of 2? Yep. Would you get the answer right? Yep. Do you have to build the table for this one? Nope. But if you did, this is 10. So I can say that my n value is 10. So this column is n, so that's got to be 10. This has to be 10 times the square root of 2. And you're done. Pretty straightforward if you're given a leg in a 45, 45, 90. Where they get a little bit more complicated is when you're given the hypotenuse. So in this next example, we're going to find the lengths of x and y. We're given this time that it's a 45, 45, 90. And we have to be told this on this one because this is x and this is y. They're two different things. So what I'm going to do then is I'm going to say, okay, this is the hypotenuse. So in my table here, this is a leg, and this is the hypotenuse. I know the length of the hypotenuse. The hypotenuse is 16. So I'm going to put my 16 there. That doesn't mean my n value is 16. It means when I multiply my n value by the square root of 2, I get 16. So I have to figure out what that n value is. So now what we can do is we can write the equation. N times the square root of 2. This value has to equal 16. So now I have an equation, n times the square root of 2 equals 16. Now, if I had 3n or 4n equals 16, what would you do to both sides? Divide by 4, right? So that's what we're going to do here. We're going to divide both sides by the square root of 2. Well, I'm not going to let you put this in a calculator. Okay, so mathematically, does anybody remember what you do if you divide by a radical? Anybody remember how you get rid of that? The way we get rid of a division of a radical is you multiply both the numerator and the denominator by that radical. Now 16 is not underneath the radical symbol. So 16 times radical 2 is just 16 radical 2. You can't combine them because one's inside of a radical, one's not. Radical 2 times radical 2 in our denominator, remember when you multiply fractions, top times the top, bottom times the bottom? Because radical 2 and radical 2 are both underneath there, you can multiply that together to get radical 4. 2 times 2 is 4. So if I simplify that, what's the square root of 4? 2. So now I've got both the 16 and the 2 that are outside. What's 16 divided by 2? 8. So this actually becomes 8 radical 2. So my n value over here is going to be 8 radical 2, making this leg 8 radical 2 as well. Now, when you do your assignment today, you can't just fill out the table. You need to put them where they go. So this is 8 radical 2, and this is 8 radical 2. Okay, so let's look at the picture. Let's see if we can draw a conclusion so we don't have to do all this work. Just like when we said we went from the leg to the hypotenuse by multiplying by the square root of 2. That's all you have to do. What's that? How would you compare 16 and 8 radical 2? In your own words. If you look at 16 and 8, what is 8 of 16? Half of it, right? Half of it times the square root of 2. And that's what it is. So for your notes, if you want to put it in your notes, put this in your notes. To go from the hypotenuse to the leg in a 45, 45, 90, it's half of the hypotenuse times the square root of 2. To go from the hypotenuse to the leg in a 45, 45, 90, it's half the hypotenuse times the square root of 2. And I'm not going to write that down because it doesn't always work. Well, it always works, but it really works well when your hypotenuse is a nice number, like 16 or 10 or 20, where that number is easily divisible by 2. Because if it's 20, it's 10 times the square root of 2. If it's 10, it's 5 times the square root of 2. If it's 60, it's 30 times the square root of 2. But what if it's 15 times the square root of 2? Now it's not so easy to do anymore. Okay, so when it's a whole number, this half times the square root of 2 really, really works well. When it's not a whole number anymore, like this one, it becomes a little bit more difficult to do. And this is why the importance of this is why I like to do the table. Because if we set up the table, we can solve for n by setting it equal to each other. Okay, so let's look at this one. So again, we got a 45, 45, 90. We have to find x and y. X and y are the legs. And we're given the hypotenuse. So I'm going to build my table. So here's my table. My tables are n, and n times the square root of 2. Remember, the first two are the legs, and the last one's the hypotenuse. What am I given? I'm given the hypotenuse. I know the hypotenuse is 8 times the square root of 2. Okay, the hypotenuse is opposite the 90 degrees. That's what I'm given. Okay, I got to find this n value so I can find the values of x and y. Okay, so I got my table. So I'm going to set my table up as an equation. N times the square root of 2 equals 8 times the square root of 2. What do I do to solve this for n? Divide by the square root of 2. Square root of 2 over the square root of 2, that's 1, so that leaves me with n equals 8 times the square root of 2 over the square root of 2. The square root of 2 divided by the square root of 2 is 1, so I'm left with n is 8. So you set up the table for this one, you solve for n, you get 8 and 8. Put it on our picture, we got 8 and 8. By setting the table up, you can set the equation up and you can solve. Is it half of it times the square root of 2? Yes, it is half of it times the square root of 2. Half of 8 is 4. So you would have 4 times the square root of 2 times the square root of 2. Square root of 2 times the square root of 2 is 4. Square root of 4 is 2. 2 times 4 is 8. You get the answer by doing half times the square root of 2, but it's too hard to do that. Set up the equation. If you can set up the equation and do it that way. Okay? Let's look at just a couple more. And why it's so important to set the table up. So the next one. We've got 2 more that we're going to do. So we've got a 45, 45, 90. I'm given one of the legs. It's this ugly thing. 9 times the square root of 2 over 2. I have to find the other leg and I have to find the r. So again, that taking it times the square root of 2 becomes a little bit more difficult. That's, again, why I like to set the table up. So I'm going to set up my table. I've got n, and n times the square root of 2. I've got a leg. I know a leg. It's 9 times the square root of 2 over 2. Well, then I know the other leg, because the other leg is n, and now I know that n is equal to 9 times the square root of 2 over 2. So this is going to be 9 times the square root of 2 over 2. So I can write that up there, because they're the same. Easy enough. Now I get down to this one. It's going to be n times the square root of 2. So I'm going to do that down here. My n value I can replace with 9 times the square root of 2 over 2. That's my n value. I have to take that times the square root of 2, which is the same thing as the square root of 2 over 1. Multiplying fractions is no problem. Take the top times the top and the bottom times the bottom. 9 is outside. There's nothing outside, so this is 9. Radical 2 times radical 2 is radical 4. In our denominator, 2 times 1 is 2. What's the square root of 4? Square root of 4 is 2, so that's 9 times 2 divided by 2. We've got a 2 in the numerator and a 2 in the denominator, so that just is 1. So our answer for this is 9. The length of the hypotenuse is just 9. Making my r value up here 9. When you have nice whole numbers, these aren't that bad. When you start getting radicals in there, it's very important that you work on being able to set up the table. I've done this different ways all along. When I gave you that rule, when I told you not to write down, 1 year, that's the whole way I taught it. And I taught you how to go from the hypotenuse to the leg to the hypotenuse for using words. Over time, I found that the table works best because you can all solve for n and go from there. Okay, I'm going to have you do one problem. This is the last one you do. I'm going to have you do this one yourself. Find the value of m and n. So make your table. But after you've made your table, make sure you write which value is which on the drawing itself. Okay, so you can find the value of m in that 45, 45, 90. Using the table. Which one do we know, leg or the hypotenuse? Leg. So we know the leg is 3 times the square root of 2. So n is equal to 3 times the square root of 2. So my second column is just n, so I can put 3 times the square root of 2. The third column is n times the square root of 2. So down here, that's going to be 3 times the square root of 2. That's just my n value. Now I have to take that times the square root of 2. Well, 3 times the square root of 2 times the square root of 2 is 3 times the square root of 4. Square root of 4 is 2. 3 times 2 is 6. I've got my table finished off. Now I'm going to go back to my drawing. This is 3 times the square root of 2. That's 6. M was my leg. N was my hypotenuse. So this is 30, 60, or this is 45, 45, 90 degree triangles. Again, keeping in mind as you're doing your assignment, these 3 pieces. In a 45, 45, 90 degree triangle, the legs are congruent, and the length of the hypotenuse is the square root of 2 times the length of the legs. Any questions?